Good morning, students. Today we will discuss the topic foundation. There are two types of foundations, shallow foundations and deep foundation. Shallow foundation. When the depth of foundation is equal or less than the width of foundation, then we can call it as shallow foundation. It is also known as open foundation. A shallow foundation is placed immediately below the lowest part of the structure. It means that the shallow foundation is just placed below the lowest part of the structure. These are the types of shallow foundation. Generally, shallow foundation is provided when the bearing capacity of soil is more and the load on the structure is less. Basically, shallow foundations are divided in five types. First is spread footing, then combined footing, and third is eccentrically loaded foundation. Fourth is mat or rough foundation, and fifth one is grillage foundation. First one is spread footing. Spread footing means here we are spreading the footing to distribute the load on the large area. The spread footings are those which spread the superimposed load or wall or column over large area. The spread footings support either a column or a wall. We can provide spread footing for a column also and for wall also. In the olden times, we are providing load-bearing walls, and these load-bearing walls have spread footing below them. Now we are providing columns, so in these columns, spread footing is provided below the column. So they are again divided in single footing for column, step footing for column, or slope footing for a column, or wall footing, or step footing for wall. So spread footing is again divided on the basis of the footing which are provided below the column or below the wall. Single footing for a column. If the building has columns, then we provide footing for each column. That's why it is called as single footing for a column. A spread footing for a single column is either known as isolated footing or pad footing. In this case, the footing may consist of simple concrete block projecting out from the column face on all sides. The base dimension of the concrete base should be not less than twice the appropriate lateral dimension of the column in that direction. The thickness of concrete block should at least be equal to side offset from the column face. Step footing for a column. We also provide step footing for columns. If the column load is more, then we provide step footing. In such a case, it is necessary to provide masonry offsets to achieve larger spread before the load is transferred to the concrete base. The height and width of each should show proportion that the rate of spread does not exceed the permissible value for the masonry. Third is slow footing for a column. Sometimes we also provide slow footings for columns. These are also provided when the bearing capacity is less and loads are more. This may be circular, rectangular, or square in plan. These are the different shapes which we provide below the column. First one is single footing, then step footing, then third one is slope footing. Generally, we provide slope footing. Step footing. A step footing consists of two or more footing of individual column by a beam called a strap. The strap beam connecting the spread footing of the two columns does not remain in contact with soil and thus does not transfer any pressure to the soil. The function of the strap beam is to transfer the load of heavily loaded outer column to the inner one. In doing so, the strap beam is subjected to bending moment and shear force, and it should be designed to withstand these. Step footings are generally provided when we have to connect the outer column with the inner column, and generally these types of footings are provided near the boundary line where we cannot transfer the load outside the boundary, because here we are restricted to the boundary line, and for each foundation we have to distribute load on the both side of the column, but in this case we have to adjust the footing such that the load remains inside the boundary line. This is the plan of step footing. These two columns are connected with a beam called a strap, and this beam is not resting on the soil. Grillage foundation. A grillage foundation is an isolated footing generally provided when heavy structural loads from columns, piers, or steel sections are required to be transferred to a soil having poor or low bearing capacity. It can be broadly divided into two categories: steel grillage foundation and timber grillage foundation. Nowadays, we are providing steel grillage foundation. In the older times, we are also providing at that time timber grillage foundation. The aim of this grillage foundation is that suppose loads are heavy and bearing capacity of the soil is limited, so we cannot increase the capacity of soil. We have to distribute the load over the large area. But if we start distributing the loads over large area, then we need more space. Then the footings of two columns overlap each other. So we need such type of foundation which can transfer the load into a limited area where we can provide grillage foundation. Steel grillage foundation. In this foundation, steel joists or beam ISMB beams are provided in two layers. A minimum core of 10 centimeters is capped on the outer side of the external beams as well as above the upper flanges of the top tier. The depth of concrete below the lower tier should be at least 15 centimeters. Tier means the layers. The first layer of the beam that is at the lower part is called the lower tier, and the second layer is called the upper tier. This is the plan of the steel grillage foundation. Here we can see that the two layers of beams are provided. In first layer, 5 steel ISMB beams are provided. Then in the second layer, 4 steel beams are provided. In the bottom layer is called bottom layer or lower layer or first tier, and the top layer is called the uh, top tier. And above that a steel plate is provided, and above that a steel column is uh, fixed with the nut bolts, and this whole system is encased inside the concrete. Timber grillage foundation, it is generally provided in the olden times, but nowadays it is obsolete because of the uh, availability of steels. So the foundation uses timber planks and timber beams in the place of steel joints. No concrete is embedded between the timber joints. However, the bottom concrete provided in steel grillage foundation is replaced by timber platform constructed of timber planks. And these types of foundation is provided where this bearing capacity of the soil is limited up to 50 to 60 kilonewton per meter square. This is the plan of grillage foundation. So friends, in this lecture we have discussed about the foundation. There are two types of foundation, shallow foundation and deep foundation. In this lecture we have discussed about the shallow foundation and its types. Thank you.